Section 5.2 talks about a parabola. We graphed parabolas already. And this is what they say. A parabola is the set of all points that are equidistant from a specific point, the focus, and a specific line, the directrix. I'll come to that in a minute. I just want to make sure that we know how to graph this. We don't need what the author is going through. So if I said sketch the graph of each parabola, label the vertex, focus, and directrix. Let's just worry about the graph for now. We'll come back to the focus and directrix. For now, we're going to sketch a graph and label the vertex. Well, if I proceed like I normally do, I figure out where does the inside equal 0. A point above it and a point below it will do. That's a 0, 1, 1, and negative 1, 1. 0, 0, 1, 1, negative 1, 1. And we know the shape of a parabola looks like this. How about if I get to this problem? Well, the same deal. If I set this equal to 0, that's at 0. A point above it and a point below it. 0, 0. A 1, 1/4. And a negative 1, you know what, I have plenty of space. 0, 0, 1, 1/4, and negative 1, still a positive 1/4. So 0, 0, 1, 1/4 is about right there. And negative 1, 1/4. So this is a lot wider than this is. This is a lot wider than this. No big deal. And what if it has a 1/5? Well, things are not going to change. If I proceed, and since in 5.2, 5.3, and 5.4, we're centering all of those at 0, 5.5, we start shifting left and right. Where does that equal 0? A point above it and a point below it. A 0 in there will get me a 0, 1/5, and 1/5. Well, the same deal as the previous graph. That is, let's say 0, 0, 1, 1/5, and negative 1, 1/5. Again, a very wide graph. So if the leading coefficient is between 0 and 1, the graph widens up. Now, if I look at this graph, I do know that this graph opens down, but no need to worry. I could do the problem the very long way. That's not a problem. And I'm just going to shrink this a bit. Here we go. Okay, so here, if I figure out where that equals 0, that is at 0, a point above and a point below, x and y. A 0 will get me 0, a 1. 1 squared is 1 times negative 3 is negative 3. So 0, 0, 1, negative 1, negative 2, negative 3, and negative 1. You know what? Since it's always centered at 0, 1, negative 1, negative 2, negative 3, negative 1, negative 1, negative 2, negative 3. So the parabola looks like this. And here the same deal. If I pick an x and a y, if I take where this equals 0, that is at 0, a point above it and a point below it, and we're kind of hopefully getting that idea. 0, 0, 1, negative 1/4, and negative 1, negative 1/4, and I notice this is a lot wider than this graph. If I was to put them on the same, that would be 1, negative 1/4, and negative 1, negative, and you would see then how wide it is. But we're not going to worry about that. That's not a big deal. I want a rough sketch. Those 3 points will do. That's more than enough. Now, we're going to come to this idea of focus and directrix. And this is how the book defines it. Actually, I'm sorry. This is not how the book defines it. This is how we're going to define it. We're going to define y to equal 1 over 4px squared is a parabola. If the leading coefficient is positive, it opens up. And if it's negative, it opens down. Okay, I could do a better job than that. Here we go. Still not liking that. Okay. And the focus is always embedded inside of this parabola. And this directrix is a line, always on the opposite side. A parabola can never cross a directrix. I'm going to call this L. So the directrix I'm going to refer to as a line which is L. And the focus, we're just going to use the letter F. And here's the deal. This distance and that distance are the same. And what is that distance? That distance is P. There's only one way of figuring out what that is. You take the leading coefficient and you set it equal to 1 over 4p, solve for p, and that tells you where p is. So here, we know the vertex is at 0, 0. I still need to label the focus, and I need to label the line. So, the way it works, I would take 1 over 4p, 1 over 4p, and set that equal to the leading coefficient. Isn't that a 1 in this case? If you cross multiply, I'm getting p to be 1/4. What does that mean? I'm going to go 1/4 of a unit above. Mark that as a focus. If I am at 0 and I go up 1/4 of a unit above, wouldn't that be 0, 1/4? And I'm going to move 1/4 of a unit below. And doesn't that make this y equal negative 1/4? When I get to the second example, example 2, I'm going to take the leading coefficient. Isn't the leading coefficient 1/4? And I'm going to set that equal every single time to 1 over 4p, no exception. Cross multiply. So p is 1. If I'm getting p is 1, and what is p? P is the distance from the vertex to the focus and from the vertex to the director. So I'm going to move a unit above. Oh wait, here you know what? I scaled it 1, 1. So I'm going to move you know what? Let me redraw this really quick. So if I was to keep the scale of 0, 0, 1, 1, negative 1, 1, I'm sorry, 1, 1/4, negative 1, 1/4. So this is a bit wider. And if I move a unit above that, that's my focus, and a unit below that is my directrix. So the vertex is at 0, 0. That's going to be the case in all of these problems. The focus, isn't that 0? And if I moved 1 unit above, isn't that 1? And the directrix is y equal. If I moved a unit below the origin, isn't that y equal negative 1? When I get to this example, same deal happens. Here it's scaled properly. I know the vertex is at 0, 0. That's no biggie. That's going to be the case for all of them. Now, when I go for the focus and the directrix, I'm going to set 1 over 5, which is the leading coefficient, equal to 1 over 4p. Cross multiply. P is 5/4. So if I move 1 to 1 and 1/4 above, label that as a focus. If this is 5/4, isn't it right there? And if I move 5/4 down, isn't the equation y equal negative 5/4? How about this problem? The vertex is at 0, 0. That we get here. And how am I going to figure out where focus is? I need to take the leading coefficient, whatever that is, and set that equal to 1 over 4p. Doesn't that mean negative 12p equal 1, and p equals negative 1 over 12? Now, p being negative means the graph opens down. P being positive, that means the graph opens up. But as you notice, we graphed the problem already. We're ahead of the game. So, p is 1 over 12. If this is 1, isn't that 1 over 12? Call that the focus. And move 1 over 12 up. and that's the directrix. The coordinates would be, the focus would be at 0, -1/12, and the directrix will be at y equal 1/12. And if I move to to the last example, this is opening down. I already have the graph. I know the vertex is at 0, 0. And if I look at the focus, so I already know the focus is somewhere down here. It has to be embedded within. And the directrix is always above, so below and above. Well, if I take the leading coefficient, now I could ignore the sign because I already graphed it. So if I take 1/4p and set that equal to 1/4, cross multiply 4p equal 4, so p is 1. That means move 1 unit below, there's the focus, move 1 unit above, draw the directrix. Y equal 1, and this will be at 0, not positive since it's underneath, -1. Now we get to the other form that we're going to be dealing with in this case, and that is x equal y squared. Now x equal y squared is something new, and instead of choosing for x, we're going to choose for y, but we're going to do the same thing. That is, we're going to figure out, since these are not functions, you're going to have to adjust a bit. You're going to choose for y being 0, the inside, a point above it and a point below it. Remember, this is the y-axis. A 0 in there, x will be 0. A 1 in there, x will be 1. And a -1 squared, that's 1. So, plotting the points in the beginning is a bit annoying. 0, 0, 1, 1, and 1, -1. So this is a sideway parabola. Something that we have not done yet, but now you're going to start adjusting to it. And based on what we said, it's the same idea. That is, you take the leading coefficient, 1/, which is 1, and you set that equal to 1/4p. You cross multiply, and you get p to be 1/4, which means, again, within the parabola is the focus, and the directrix is the opposite side because the parabola can never cross the directrix. So the focus would be, in this case, at x equal 1/4, y equals 0, and the directrix will be not y, it will be x equal -1/4. Now something I want to show you, I will take time to do that, and maybe I'll do it on that problem right there. A trick I want to show you that will work for any of those that are not functions. In this case, one way of doing this problem is for you to proceed like we just did on the last problem. You could say, you know what, I'm going to pick values for x and y. I'm going to pick y because that's the square. Y equals 0, a point above and a point below. If I put 0 in there, I'll get 0, 1/3, and 1/3. 0, 0. 1/3 for x, 1y, and 1/3 for x, -1/3 for y, and we know the sideway parabola looks like this. A bit wider than the traditional. We know the vertex is at 0, 0. We know the focus is somewhere in there, and the directrix is somewhere to the left. It's x equal a number. And we take the leading coefficient, which is 1/3, and we set that equal to 1/4p, cross multiply, and p is 3/4, so you move 3/4 of a unit, and 3/4 of a unit, you put a line, and we know this vertex is at 0, 0, we know the focus is at, if I am at 0 and I move p, which is 3/4 of a unit to the right, that's 3/4, 0, and the directrix is x equal -3/4. Something I want to show you if you're struggling with this. Or, and it's worth noting, or I take this okay, I'm not sure what it copied. I thought I got this. Here we go. There it is. Or you could say, you know what? I don't like this sideways, especially when we shift later on, it's going to be a bit confusing. Instead, you end up doing, you switch X with Y. And you say, okay, everything I'm doing right now is rough. That's not the answer. I know this is a parabola that opens up and it's a bit wide, no biggie. I get it. And I know the vertex is at 0, 0. Now, if I want, I could pick points. I could say X and Y. If X is 0, Y is 0, X is 1, Y is 1/3. Since I'm used to this, probably I'm better off doing something like that. And I could say the focus is at 0 and somewhere up there, right? And the directrix is Y equal. And I could take 1 over 3, set it equal 1 over 4. P cross multiply. And P is 3/4. So since that's 3/4, and that's 3/4, you could do that. But here's the catch. When you come to the actual problem, I'm going to erase this and restart, assuming you did that. So you're doing all of that extra work, which doesn't take as long as you think, but it does worth doing. You could say, you know what? This is how I did the problem. Now what? Didn't we switch X with Y to get here? Switch X with Y. I have a vertex. If you switch X with Y, isn't that at 0, 0? I have a focus at 3/4, 0. And I have a directrix, Y equals, switch X with Y, X equal negative 3/4. You see that point 0, 0? Switch X with Y. Switch X with Y, 1/3, 1. And switch X with Y, 1/3, negative 1. There's the graph. The focus is at 3/4, and the directrix is X equal negative 3/4. You could always do that if you wish. It's a bit more work, but if you're having a hard time with this, it's worth doing. For example, I could start this problem right here and say, you know what, let's do Y equal negative 2x squared. I strongly suggest that to students that struggle with graphs, but that's only me. If I let X equal 0, especially when we get to the shifted, here it's not going to seem much of a work. That's a 0. X equal 1, negative 2. X equal negative 1, negative 2. Remember, all of that is extra. You really don't need to do that if you don't want to, out of mind. But now, if I look at how this graph looks, again, this is a rough sketch. You could do it on 0, 0, 1, negative 2, negative 1, negative 2. So something like this. No biggie. The vertex is at 0, 0. And the focus, I will take 1 over 4p, set it equal to the leading coefficient, which is a negative 2. So that work doesn't change. Cross multiply. So p is negative 1/8. So if I go 1/8 below, that's 0, negative 1/8. And the directrix is Y equal, if I go 0 above, that's 1/8. Well, to get to the actual graph, switch X with Y. The actual vertex is 0, 0. The focus is at negative 180. And instead of Y equal, if you switch X with Y, X equal 1/8. So I have a vertex at 0, 0. Negative 1/8, 0 is the focus, and 1/8 is the directrix. And if I switch X with Y, 0, 0, negative 2, negative 2, 1. X equal negative 1, negative 2, 1. And if I switch X with Y, negative 2 for X, negative 1. And you know the shape because the graph can never cross that line. And there it is. And if I go for the last graph, again, you have multiple options. I'm going to do this straight. It's up to you. I'm going to choose values for y, and I'm going to say, where does y equal 0? A point above and a point below, 0, 0, 1, negative 1/4, negative 1, negative 1/4, 0, 0. If x equal negative 1/4, y equal 1, there's the graph. Got it. Wider than usual. I know that the vertex is at 0, 0. It's given. I need the focus, so I know it's going to be and x equal, and I'm going to take, again, you could ignore the negative since we already graphed it, 1 over 4p equal 1/4. That means p is 1. So move a unit away. That makes this a negative 1. And a unit to the right. That makes this a 1. And there it is. Now, the rest of this is straightforward. There's nothing they could do if you understand what we just did. Write what we did. Write the standard form of an equation. Vertex at the origin. Either you're going to write y equal 1 over 4p x squared, or you're going to write x equal 1 over 4p y squared. So, even though they're not asking for a graph, a rough sketch will do, meaning they're not asking for a graph, but if they say the focus is at 0, negative 6, the focus is at 0, negative 6. 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. That's the focus. Doesn't that mean the parabola opened down? And doesn't that mean that's what P is? So isn't it y equal, since it opens down, isn't that negative 1 over 4 times P? And what's P? Isn't P the distance from the origin to the focus? Isn't that 6 units? There it is. Now, I believe your book will say x squared equal negative 24y, which is the same thing. But that's how we want the answer. How about if they told us, okay, here's another graph. Again, a graph is not part of the problem. You have a directrix at x equal negative 5. 1, 2, 3, 4, 5. There's the directrix. The vertex is right there. Doesn't that mean it opens to the right? Isn't that x equal 1 over 4 times p x, so used to x, y squared? Well, what's p? Isn't p the distance from the vertex to the actual directrix? Isn't that 5 units? Or x equal 1 over 20 y squared. The back of the book will have y squared equal 20x. So it doesn't matter. And how about this last problem? It says a parabola passes through the point 2, negative 2. And the axis of symmetry is horizontal. Remember, it must pass through the vertex, the origin. That's what they told us. So since the line is horizontal, doesn't that mean that it must look like this? Because the axis of symmetry is horizontal. Which means x equal 1 over 4p y squared. What do I need to find? I need to find p. Do you see they gave us a point? Doesn't this point on the curve always satisfy the equal? X equal a 2 when y equal a negative 2. Doesn't that mean that 2 equal, isn't that 4 over 4p? Those cancel out. So if I cross 2 equal 1 over p, if I cross multiply 2p equal 1, p is 1/2. What does p equal 1/2 mean? That means you take that equation and you write x equal 1 over, and if I put a 1/2 in there, what's half of 4? Isn't that a 2? And that would be the answer. And there's your homework. On 1 through 6, all 23, 24, and 25, the directions, ignore the directions in the book. A graph, label the vertex, the focus, and the directrix, just like we did on all of these examples.